A nuclear weapon. Both bomb types release large quantities of energy from relatively small amounts of matter. The first test of a fission bomb test released energy approximately equal to 10 million tons of TNT. A thermonuclear weapon weighing little more than 2,400 pounds can release energy equal to more than 1.2 million tons of TNT. A nuclear device no larger than traditional bombs can devastate an entire city by blast, fire, and radiation. Since they are weapons of mass destruction, the proliferation of nuclear weapons is a focus of international relations policy. Nuclear weapons have been used twice in war, both times by the United States against Japan near the end of World War II. On August 6, 1945, the U.S. Army Air Forces detonated a uranium gun-type fission bomb nicknamed Little Boy over the Japanese city of Hiroshima. 3 days later, on August 9, the U.S. Army Air Forces detonated a plutonium implosion-type fission bomb nicknamed Fat Man over the Japanese city of Nagasaki. These bombings caused injuries that resulted in the deaths of approximately 200,000 civilians and military personnel. The ethics of these bombings and their role in Japan's surrender are subjects of debate. Since the atomic bombings of Hiroshima and Nagasaki, nuclear weapons have been detonated over 2,000 times for testing and demonstration. Only a few nations possess such weapons or are suspected of seeking them. The only countries known to have detonated nuclear weapons, and acknowledge possessing them, are the United States, the Soviet Union, the United Kingdom, France, China, India, Pakistan, and North Korea. Israel is believed to possess nuclear weapons, though, in a policy of deliberate ambiguity, it does not acknowledge having them. Germany, Italy, Turkey, Belgium and the Netherlands are nuclear weapons-sharing states. South Africa is the only country to have independently developed and then renounced and dismantled its nuclear weapons. The Treaty on the Non-Proliferation of Nuclear Weapons aims to reduce the spread of nuclear weapons, but its effectiveness has been questioned. Modernization of weapons continues to this day. There are two basic types of nuclear weapons: those that derive the majority of their energy from nuclear fission reactions alone, and those that use fission reactions to begin nuclear fusion reactions that produce a large amount of the total energy output. All existing nuclear weapons derive some of their explosive energy from nuclear fission reactions. Weapons whose explosive output is exclusively from fission reactions are commonly referred to as atomic bombs or atom bombs. This has long been noted as something of a misnomer, as their energy comes from the nucleus of the atom, just as it does with fusion weapons. In fission weapons, a mass of fissile material is forced into supercriticality, allowing an exponential growth of nuclear chain reactions, either by shooting one piece of subcritical material into another or by compression of a subcritical sphere or cylinder of fissile material using chemically fueled explosive lenses. The latter approach, the implosion method, is more sophisticated than the former. A major challenge in all nuclear weapon designs is to ensure that a significant fraction of the fuel is consumed before the weapon destroys itself. The amount of energy released by fission bombs can range from the equivalent of just under a ton to upwards of 500,000 tons of TNT. All fission reactions generate fission products, the remains of the split atomic nuclei. Many fission products are either highly radioactive or moderately radioactive, and as such, they are a serious form of radioactive contamination. Fission products are the principal radioactive component of nuclear fallout. Another source of radioactivity is the burst of free neutrons produced by the weapon. When they collide with other nuclei in surrounding material, the neutrons transmute those nuclei into other isotopes, altering their stability and making them radioactive. The most commonly used fissile materials for nuclear weapons applications have been uranium-235 and plutonium-239. Less commonly used has been uranium-233, neptunium-237, and some isotopes of americium may be usable for nuclear explosives as well. But it is not clear that this has ever been implemented, and their plausible use in nuclear weapons is a matter of dispute. The other basic type of nuclear weapon produces a large proportion of its energy in nuclear fusion reactions. Such fusion weapons are generally referred to as thermonuclear weapons, or more colloquially as hydrogen bombs, as they rely on fusion reactions between isotopes of hydrogen. All such weapons derive a significant portion of their energy from fission reactions used to trigger fusion reactions, and fusion reactions can themselves trigger additional fission reactions. Only 6 countries, United States, Russia, United Kingdom, China, France, and India, have conducted thermonuclear